This is example 3. And before I go on, you might... Okay, so in May, you're going to take a Algebra 1 EOC. You're allowed a calculator. All of you have different calculators. There are regression problems on the EOC, so please be familiar with your graphing calculator and how to do linear regressions, quadratic regressions, and exponential regressions on your specific graphing calculator. If you have TI-84s or TI Inspires, I can find out the steps to help you do that. If not, please Google that or get in contact with me and I will find somebody that knows how to do the regressions on your calculator. You are allowed a calculator. We'll talk to the different schools to figure out how we will let the virtual students clear calculators and see if they're going to have you use the school provided one or the one you have been using. I know that you will not have access to Desmos. This is just a teaching tool so we can show you how regressions are done on a graphing calculator. They're a little bit different for each calculator, but not that much. Okay, so regressions can be used to find equations or functions for patterns or sequences, whether it be linear, quadratic, or exponential. There's others also. There's arithmetic and there's geometric. So here's an example. The regular polygons below form a pattern. And so anytime you have a sequence, you're going to label this as spot 1, spot 2, spot 3. So you are going to create a table where the nth figure, which is the 5th figure, 6th figure. So the first figure, and we're going to, that can be, write an expression that can be used to determine the perimeter of the nth figure. So the first figure, this is figure, and this is perimeter. So first and second and third figure is 6 and 12 and 20. Okay. One of the things that sorry, babbling. So you're now going to find out whether it's linear, quadratic, or exponential. And this is a data set, and if it is a linear, a regression of 1, r squared is 1, quadratics do this. Okay, so you know how to do linear. You're going to go plus 6, plus 1, plus 8, plus 1. 6 over 1 and 8 over 1 are not the same. It is not linear. Here's the interesting thing, and I've alluded to it in previous videos, but to check a quadratic, it's called second difference. And if you needed a longer table, but if this second difference is the same all the way down, then it is a quadratic. We can't tell with just 3 data sets. The next thing we're going to do is we're going to go back to Desmos, and we are going to create a table. We're going to put in our data points of 1 and 2 and 3, and we don't need 4. And we're going to do 6 and 12 and 20. And then we are going to check if it is linear. Y equals mx plus b. We need the 1s. So it'll give it to us 0.9932. That's pretty strong. Okay, now we're going to do quadratic. Oops. Y equals ax squared plus bx plus c. And then we're going to have to put in our 1s. happened to my table? Ah, my table disappeared. 1. Let's see what happened. Maybe I can't do it. Oh, I had an equal sign, I bet. Oh, sorry. AX squared plus BX1 plus C. Every little thing. Ooh, perfect regression. Perfect regression. So now we know that our equation is x squared plus 3x plus 2. So we're going to come here and we are going to fill in, we're going to say it's a quadratic expression. And our thing is n squared plus 3n plus 2. We replace the x's with n's. Anytime n is in an equation, that's a tip-off that they're doing a sequence. What is the perimeter of the 7th figure? 7 squared plus 3 times 7 plus 2. Or we can come back here and we can say y equals 3, x squared plus 3x plus 2. We can turn everybody off, go up to the cog, tell it I want a table, and I want the answer for 7, and that is 72. 72 inches. If not, that would be 49 plus 21 plus 2. It would still give me 72. Whether you do it whether you do it long ways or short ways. So you can plug it in. Again, if you use Desmos, please take a screenshot. Okay, write an expression that can be used to determine the perimeter of a figure with n sides. Okay, so instead of doing figures, figure 1, figure 2, figure 3, we're now going to do sides. A side of 3, a side of 4, and a side of 5. So a side of 3, this is number of sides, and this is still perimeter. So 3 gives me 6, 4 gives me 12, and a pentagon gives me 20. Going to go back to Desmos. Oh, I'm going to check this. This is 1 and 1. This is 6 and 8. And this is 2. We still can't do second differences because our table's not long enough. We're going to go back to Desmos, turn some things off. Okay, we are in Desmos to do the next, to do the input of the table. We have 3 and 4 and 5. We have 6 and 12 and 20. We're going to see if it is a linear. y1 equal, I always do the equals, tilde, regression thing, mx1 plus b, check r squared, 0.9932, pretty close. Y1 regression, ax1 squared plus bx plus c. Oop, didn't do my 1 on my x. All these little things. Oh, perfect regression. So it is a quadratic. And see this where it's negative to the negative 15th. It's slightly off a 0, but it's got so many zeros that we're not going to care about it because it's like 0.00, and remember I said take it out to the hundredth, so if you rounded that, that would be 0. So we are going to do this as a quadratic because r squared equals 1, which means it's a perfect fit. So this is x squared minus, oh, we're using n's because we're doing a sequence, n squared minus n, and we're going to do the 7th side, so 7 squared minus 7, and that's 49 minus 7, which is 42. So a 7-sided would have a perimeter of 42. Let me go here and I'm going to show you on this table. I'm going to add some tables. So this would be 6 and 30. And this would be 7 and 42. And it's still doing the same thing. Let me turn this off. And it still has the regression of 1, and it's actually getting more and more accurate. And then I'm going to come back here and actually show you a quadratic with a second difference. So I filled in the table more, and remember we were doing differences, and this is 10, and this is 12, and my second difference is 2, and my second difference is 2, and all of these match. That confirms that it's a quadratic. So if you have a lengthier table and you can do that, the second differences match, that's the other way to tell if something is a quadratic. Okay, example 4. Oh, video's getting long. We're going to do the next example in the next video.